Yes, good evening. Welcome, my people. Thank you for joining us today. Thank you so much for joining us. Good evening to you. I'm doing well. I'm doing well, thank you. So, how are you guys doing as well? Hope you guys are doing well. Okay, so that's good to know. Thank you for the likes. For people who are sharing the live already, thank you. You already know how we do it here. You already know how we do it here, so thank you so much. Let's see what we can do today. We're going to be doing a lot. I probably have a lot of time. We're going to do so many things. So don't stop sharing. Don't stop sharing the live. Maybe we'll just start off with physics today. We'll start off with physics, especially the aspect called the heat energy. Let's do a lot of calculation on the heat energy. And then after physics, sometimes we switch to mathematics, sometimes switch to chemistry. We're going to be doing the three simultaneously. So please stay active. So question 1, please confirm if you can see the board clearly. Good evening and welcome. Okay. All right. So let's start. You know how we start now? We can start anywhere, and you can start anywhere and end anywhere. Okay, so since our focus is on heat energy, let's solve problems under heat energy. So the first question I'm having is for us to convert negative 29 degree Celsius to absolute scale of temperature. So keep in mind we are doing calculation under heat energy. So the first question is for us to calculate negative 29 degrees Celsius to absolute scale of temperature. So what do you think the answer is? Put it in the comment section. Everybody attempt. Please be ready. Get your writing materials. Get your writing materials. Everybody attempts the problem first. Any answer so far? Let's try out the solutions together for those persons who might not be able to attempt. Brilliant, fantastic. I think I'm seeing people dropping answer. Fantastic. You guys are super intelligent. Congratulations, guys. Okay, so let's work out together. You know, whenever you're asked to calculate from degrees Celsius to this temperature, absolute scale of temperature. So the first thing you want to do is to use this particular formula. T subscript K equals 273. Don't forget this two. Even if they add 0.15, it's not a problem. The same thing. Plus T degrees Celsius. This T degrees Celsius is the given temperature. So that means you'll be having 273 plus, remember this T degrees Celsius was, the value is 29 degrees. 29. So what this means is that plus, we multiply this minus to give you what? Minus. So 273 plus minus is minus 29. So everybody add and tell me the final answer. Use a calculator. Be fast about this, please. Add and let me know the answer. Apart from those people who solved it even before I solved, to show that these guys are really set. These guys are really set for the exams. We're going to be pushing it bit by bit until we leave this stage, we enter another part. You're going to succeed in Jesus' name. None of you will fail. None of you will fail. Yes, some person says 244. If this is what you're having as a final answer in Kelvin, oh, please, very important, then you're absolutely correct. Congratulations to you guys. None of you will fail. Next question, please. Yeah, we don't have time for you to start copying. What you need to do is to screenshot, to snap. Question 2. Convert, everybody start solving this one. Convert 20 degrees Celsius to Fahrenheit. Fahrenheit scale. That's the second question. Convert 20 degrees Celsius to Fahrenheit scale. Assuming you are in exam hall and this was the question 1, a lot of you got this answer correctly. That means you've earned 2 marks for free. This is question 2 in your exams, impromptu tests, impromptu exams. What can you do? Just see what you can do about this one. I'm giving you guys 2 minutes to figure this out. If you're not able to do that, that's when we just do it, move to the next question. Okay, let's start solving then. Let's start solving. Let's see what you have, if it is correct. So the formula we're going to be using for this is F minus 32 divided by 9 equals C over 5. I can put this formula in different formats and still use it to solve. We will still get the same answer. So now, remember that you're converting this 20 degrees Celsius to Fahrenheit scale. So that means you're making this guy the subject of the formula. And at this point where you're having this particular C, that's when you're putting this value. It's as simple as that. Then you play around with this to get the value of this F. That's all you need to do. I can see somebody say the answer is that 128? Somebody said 6.67. Somebody said, I don't know, is that 253 also? I can see different answers. I don't know why you're having different answers. Let's see what works then. It's okay to have different answers as long as you're learning here. But please, don't have different answers when it is time for exams. You can have different answers right now, but you should end here. All right? All right. And I hope you're sharing this live stream to your friends to come and join us to learn. If you're not doing that, it means you're saying, instructor, just stay only 1 hour or 45 minutes. Then I'll just do physics and leave for today till next time. So make sure you share this particular video. Always hit that like button. Share this particular video to your group chat, your status, your Facebook page, everywhere, so that people come and learn for free. All right. That being said, F minus 32 divided by 9 equals, this C now is 20 divided by 5. Okay, so what do we need to do next? It's pretty simple. If you want to divide this one to give you 4 and then use it to do your work, no problems. No problem, absolutely okay. But if you don't want to do it like that, want to cross multiply too, still okay. Cross multiply means taking 5 over here, so that 5 into F minus 32 equal to 20 times 9. 20 times 9. If you do it like this, it's still fine. Anyhow you follow it, just make sure you do your thing properly. Distribute this 5 times F will give us 5F minus, class, what is 5 times 32? Everybody, let's go. What is 5 times 32? I'm waiting for your response. What is 5 times 32? Good, 160. That's correct. What about 20 times 9? Please, let's be together tonight. Let's work together tonight. So you have to be responsive. You have to be very, very responsive. What about 20 times 9? I'm thinking 9 times 2, 18. So that will be 180. Is that correct? Is 180 correct? Okay, somebody is saying 180 already. Is that 180? Good. So if we add this 160 to both sides, or the way you like doing it, take this over here. So we have 5F equals 180 plus 160. Class, what is 180 plus 160, please? What is 180 plus 160? What is 180 plus 160? Somebody said 340. Is that correct? Let's put that answer down. If you divide both sides, or ask yourself, what number is it that if 5 multiplies by that number, it gives you 340? That's the smart way to get the answer. But if that would be difficult for you, divide both sides by 5, divide both sides by 5. This cancels out. F now will be equal to, what is 340 divided by 5, class? What is 340 divided by 5? What is 340 divided by 5? 68. 68 degrees is the final answer. Did you find this helpful? Guys, did you find this helpful? If you find this helpful, please snap. You want to screenshot, because we are moving next to another question. We are moving to the next question, please. If you want to snap, you snap. If you want to snap, we snap. We are still on heat energy. We are solving question under heat energy. Are you done snapping? Are you done snapping? Please confirm to me if you're done snapping. All right, next question. So the next question says, all the heat, this is question 3. All the heat generated in a 5 ohm resistor by 2 ampere flowing for 30 seconds is used to evaporate 5 grams of a liquid at its boiling point. Now the question is, what is the specific latent heat? If you know you're preparing for UTME exams, take this thing seriously. You're in 100 level, take this seriously. You're preparing for WIC, take this seriously. SS1 to 3, take it seriously. UTME exams, JAM, take it seriously. JUPEP student, take it seriously. Pre-degree, take this thing seriously. These are the topics I selected that cut across all of your syllable. You need to take this particular one seriously. Specific latent heat of the liquid. Now they also give the instruction that this is question mark, that you should leave your answer, leaving your answer in joule per gram. Now they have already told you to leave your answer in joule per gram. You can see that you don't need to bother converting this mass from gram to kilogram. Remember, in chemistry, when we see grams, we measure mass in grams for chemistry, but for physics we measure it in kilograms. So but then when you see it in grams, you usually convert it to kilogram and use it to solve our problem. But here they have already placed the unit in grams already, so there's no point converting. So if you're able to bring out the parameter, you're able to know the formula for this, then you're good. Two things: bring out the parameter, know the formula that connects it, then you're good. So let me know if I should start solving. Let me know if I should start solving. All right, solution. Okay, let me see the comments. I have not been checking my phone. Somebody says start, sir. Okay, let's move ahead. Now, remember they said you should find the specific latent heat of the liquid. First of all, what is the formula for specific latent heat of liquid? It's pretty simple. It is usually equal to, have you seen I squared ROT, which is equal to ml? So you're going to equate this I squared ROT to ml. And if you check, all these parameters are captured there. Why? If you check, you see all the heat generated in a 5 ohm resistor is given as 5 ohms. By 2 ampere, the current is given as 2 ampere. Flowing for 30 seconds, the time is given as 30 seconds. Is used to evaporate 5, the mass is given as 5 grams of a liquid at a boiling point. What is the specific latent heat of? So this is the L you're looking for. This L is standing for specific latent heat of liquid. Then M is for the mass, T is for the time, R resistor and time, and I is for current. Is that clear? So with that information now, you can plug everything into the formula. The formula is I squared ROT equal to ml. So your I is already 2, but you square it because of this square. R is 5, multiply that by 5 times your T is 30 equal to your M is 5. 5 times L, that's 5L. So 2 squared is 4. 4 times 5 is 20. Class, what is 20 times 30? Class, what is 20 times 30? Please, let's be active in the comments. Did you say 600? Okay, let's have 600 equal to 5L. If we divide both sides by 5, this cancels. Therefore, L will equal to, what about 600 divided by 5? What about 600 divided by 5? What about 600 divided by 5? 120. Remember what they said we should put our answer. Can you still remember? Can you still remember in the instruction, leaving your answer in what? Can you still remember? Please pay attention to the instruction. That's very important. Can you still remember what they say we should keep our answer? Very good. Somebody has said it. Joule per gram. Very important. Joule per gram. So if you see that option, just take it. Snap if you want to snap. Want to do the next question. Because you won't know when I'll start removing the paper. I think it's about time to remove the paper because this space might not be enough for me to solve the next question. Or maybe I'll just manage the space. Snap if you want to snap. Snap if you want to snap. Can I proceed? So the question says, an electric current of 3 ampere flowing through an electric heating element of resistance 20 ohms. 20. Come, if you guys are tired of physics, people should tell me. Oh, I can switch to mathematics easily. But I know that physics is very important. If you're tired of physics, you tell me, I can switch. If you're tired of physics, you let me know, because I have a lot of things I needed to solve under this heat, and I just want to cover heat energy as much as I can. Then I know that we have achieved something. Okay, with your comment, it looks like you want me to continue with physics. All right, let's keep going. So, an electric current of 3 ampere flowing through an electric heating element of resistance 20 ohms embedded in 1000 grams of an oil raises the temperature of the oil by 10 degrees Celsius in 10 seconds. Then what is the specific heat capacity? What is the specific heat capacity of the oil? Now remember, the other one was specific latent heat of liquid. This one is specific heat capacity. So you need to pay attention to these things. You need to pay close attention to these things, because they are very, very important, so you don't misinterpret this particular formula. So you don't misinterpret the formulas. You need to pay close attention to these things. So now, how do we get this done? First thing first, you are asked to find the specific heat capacity of the oil. Other informations have been given to you. Just keep in mind that from the question, they say an electrical current of 3 ampere flowing through an electric heating element of resistance, this embedded in this of an oil rises the temperature of the oil by 10 degrees Celsius. And what is the specific heat capacity? Just note that. The solution. I think I need another paper. Or let me manage this space. Just know that solution. Just know that heat energy is equal to electric energy. This is the first thing I want you to know, that heat energy is equal to electric energy. So in that case, for the heat energy, we have mc theta equal to electric energy, that is I squared. We've used this before, ROT. I squared ROT. This one is for electric energy. This one is for heat energy. Now, it's because all the information are combined together. That's why we are using two of them. So what do we need to do already? Some people already put in the answer in comment section. I don't know if the answer is correct, but then let's see what we have. So in this case, you can see that the mass is clearly given. The mass is clearly given in the question. Look at it. Let me point them out. The mass is clearly given here as 1000. So you have 1000 times the C is what you're looking for. C is standing for specific heat capacity. Please put all this information down. C here is talking about specific heat capacity. That's what you're looking for. Times the theta. This theta now is given as 10. Look at it here. 10 degrees. That's the temperature. Is 10. Equal to I. Current is given also. Check. Current is 3 ampere. But you have to square it because of the square that comes with the formula. Times arrow. Arrow is given as 20. Look at it here. The resistance is given as 20 times T. The time also was given as what? Please, guys, what is the value of the time? Look into this place and tell me. What is the value of the time given? What is the value of the time given? Please, you guys has to be fast. This class is just an hour class. If you guys are not fast, we may not be able to do so much. Good, 10. Look at it here. The time is given as 10. So you put 10 here. So let's move to the next one. This value, which is 10, multiplied by this 1000. Of course, you know it's going to give us 10,000. So we'll be having 10,000 C, 10,000 C on this part, equal to 3 squared is 3 times 3, which is 9. If 9 times, okay, here is 20. 20 times 10 is 200, right? 200 times 9. Guys, 200 times 9 is what? 200 times 9, is it 1,800 or what? Because I'm reasoning 2 times 9 is going to be 18. Then add this to 0 to it. Is it 1800, right? 1800, awesome. So you're looking for C, divide both sides by 10,000. Divide both sides by 10,000. This cancels out. So C will be equal to 1800 multiplied by 10,000, divided by 10,000. If you want to reduce the 0, you can go ahead and reduce the 0. So you just have 18 divided by 100. This is even easier for me to say 0.18. The unit for specific heat capacity is always joule per gram per degree Celsius. That's the unit. Does this make sense? Did you learn from this? Does this make sense? Did you learn from it? Can I bring more question? Snap, snap. I want to remove the paper right now. Everybody, snap. I want to remove the paper right now. I hope you guys are sharing the live. While I'm about to bring the next question, please, everybody get involved. Immediately you're done snapping, please don't copy because I want to remove the paper. Just snap. Later, I copy it in your notes to save time. Everybody share this particular live to your status. If you want me to stay more than I'm supposed to stay, share this particular live to your status, your Facebook page, your TikTok page, everywhere. Just share it. Your group chat, the group chat where people are preparing for exams. Let them come and learn. And if I'm not able to do chemistry today, don't get worried. If I'm not able to do chemistry, just know that as I'm coming to the live next time, maybe this week also, I'm coming for chemistry. It might be organic chemistry, it might be stoichiometry, it might be just something simply focusing on calculation under electrolysis, because a lot of students have been asking about stoichiometry and also electrolysis. I may just come to deliver the lectures on that. So if you are focusing on physics, we can just focus on physics. If you are coming to maths, we just focus on calculus and do a lot of calculus. So please make sure you share the live. Everybody get involved in it. I want to remove the paper right now. Please don't spam. I don't see somebody is spamming, sending the same message 3 times. I will end up blocking you. You not have access to the live stream. Don't do that. Please be organized. You just stay organized whenever you're on my live stream and learn, please. Very important. Because I don't like coming to waste my time. I'm coming to give students value. And that's why I'm doing this class for free. These are supposed to be exclusive lectures for my students who pay for my private lessons. But I'm bringing it up here for free of charge. So don't take advantage. Don't joke with that. If I catch you doing any of that, will limit you from learning from this space. Very important. And please follow instruction. If I say share the live, join up to share. Join up to share. Very important. I have reasons for which you need to do that so that other students come and learn alongside, because they're not aware. All right, so see the question. The next question is this. Let me adjust this thing a bit. Good. So here's the next question. A temperature scale has a lower fixed point of 40 millimeter and upper fixed point of 200 millimeter. What is the reading on this scale when a thermometer reads 60 degrees Celsius? So that's the next question we're going to be working on. Everybody pause and attempt the problem. Everybody pause and solve. Okay, I usually give short time because I expect you to use not less than 15 seconds to solve a problem. If it gets too much, maximum 1 minute. You should be able to fix one problem. If you stay more than 1 minute, it means you never have known the topic very well. You have to be very fast because you do not really have time for these exams. So, that being said, because I'm teaching, I have to explain everything step by step. So, solution. When you see problems like this that has to do with upper fixed point and lower fixed point, this is what you want to do. Please learn this once and for all. Everybody pay attention, please. This is how I usually solve it. I just put something like this, a parenthesis or square bracket like this, that will house these parameters. Remember, the first thing that was mentioned, I think we have, watch, a temperature scale has a lower fixed point of 40. So you can see that the lower fixed point is 40 millimeters. So this is the lower part, this is the upper part. On the lower part, I will just put 40 millimeter. And an upper fixed point of 200. So on the upper, I'll just put 200 millimeter. Is that clear? Please answer me fastly. Is that clear? Everybody respond to me. Is that clear? Did you get what I just did? Is that clear? Good. So I read through the question. That was what I did. I just, first of all, I brought in this square bracket. And then I read through the question. A temperature scale has lower emphasis on lower fixed point of 40 millimeter. I came to the lower part and I put 40 millimeter, and an upper fixed point of 200 millimeter. I came upper and put. That's the simple thing I just did. I was surprised I saw somebody said no. I suppose it should be clear right now. Okay, let's move forward. Now, they didn't finish. They say, what is the reading on the scale when a thermometer reads 60 degrees? So when the scale is always the temperature scale is ranging from 0 degrees to 100. I mean from 0. That means the lower part is going to be 0 degrees Celsius to 100 degrees Celsius. From 0 degrees Celsius to 100 degrees Celsius. Now they are saying that what is the reading on the scale? That's what is the reading on this scale, on this particular part. What is the reading? That's X. What is the reading on this particular part when the scale of the thermometer reads 60 degrees? So when it is 60 degrees at this particular point, what will be the value of this particular part in millimeters? Remember, this is the lower, this is the upper. By default, this is the lower of temperature and this is the upper. Now they have not given you us this particular value. The temperature reads this particular value. What's the scale? What is the reading on the scale on this particular part? So you just put it as X because we don't know what that is. Is that clear? So just put X because we don't know what that is. From here you can fix your equation and then you solve. How do you fix equation? Just say this X minus the lower. Look at it. X minus the lower, which is 40, divided by this this one minus this divided by this one minus this. So I'll use X minus 40 divided by 200 minus 40 divided by 200 minus 40. That same thing I will do it equal to, I'll do it here also. I will say 60 minus 0. 60 minus 0 divided by 100 minus 0 divided by 100 minus 0. Is this clear? Is this clear? If you've not joined if not registered for our April class, the discount is there, 7,500 from now till 1st of April. Immediately it gets to 1st of April, then it becomes 15,000. Please make sure you join this particular Telegram platform. The videos are much there that they can benefit from, both math, physics, chemistry. So that's the information for you. I said, is this clear? Please type clear if it is clear so I move forward. If it is clear, type clear so that I'll move forward. So of course here is X minus 40, but let's work on this one because this particular X minus 40 will remain like that. So literally you're having X minus 40 divided by, what is 200 minus 40? Class, what is 200 minus 40? Class, what is 200 minus 40? Class, what is 200 minus 40? Somebody said 160. Let's plug in 160 there. Equal to 60 minus 0 is 60. 100 minus 0 is 100. Let's cross multiply. How do we cross multiply? 100 will multiply these two things. Look at it. 100 into this X minus 40 equal to 60 times this 160. Please be fast about this one. Please work with me. 100 times X is 100X. I will help you on that. 100 times minus 40 is minus what? What is 100 times minus 40? What is 100 times minus 40? Could that be 4,000? What is 100 times? Good, 4,000. What is 60 times 160? Somebody should help. 60 times 160. I think 16 times 6 should be around 96. Is that 96? No, I'm not sure. I'm not sure about these things anymore. Just 36, 6 carry 3. Yeah, 96. So Maybe 9,600 or 96,000 or something. Don't know. Please use a calculator. Is it 9,600? 60 times 160. Awesome, awesome. 9,600. I think my brain is still working so fine. Good. Because I don't have calculator in this house. That's why it makes me to think very fast when I do all these kind of calculations. So now if you move this guy, you can either say add 4,000 to both sides, or you can just move it as well. So this becomes 100x equal to 9,600 plus 4,000. Please add up this, add up this, add up that. What is 9,600 plus 4,000? What is 9,600 plus 4,000? I'm suspecting that this thing is supposed to give us up to 13,000 something. Good. Somebody's saying 13,600. Let me put that down. 13,600. So if you divide both sides by 100, divide both sides by 100, I think everything is finished now. This 0 will cancel 0. You can see that the answer is crystal clear. X will be equals 136 millimeter. That means when we have the temperature at this particular 60 degree, when the temperature reaches 60 degrees, this value of the reading here, the reading on the scale is going to be 136 millimeters. Does that make sense? Did you learn from this calculation? Did you now understand this kind of calculation? Some of you are just learning this one for the first time. You're just getting to know this type of calculation for the first time. Shockingly enough, it usually come in exams. Different exams have tutor students, even till 100 level. This kind of stuff comes in exam. So take it so seriously. Are you enjoying the class? Are you enjoying the class? Please snap. Please snap, because I'm about to remove it. Please snap. If you are really enjoying the class, don't forget to hit the like button. And if you're here, if you've not subscribed to the YouTube channel, you're missing out, because when I come live next time, you will not receive notification. If I were you, the first thing is to hit that red button, that subscribe button. And after hitting the subscribe button, turn on the bell icon, that thing that looks like bell close to the subscribe button. Turn it on and select all. That will not help you anytime I come live stream. Even though you're not aware that I posted that I will be coming live, you will just automatically receive notification. Even if I post video, you receive notification. So if you've not hit the subscribe button, do that right now. I'm giving you time to hit the subscribe button, turn on the bell icon. If you have done that before, you don't need to do that. Just share the video. If you've done that before, you don't need to do it twice. You only just subscribe once. Hit the subscribe button real quick. Let's proceed. If you're subscribed before, just type done. If you're just subscribing, type done. If you're ready for the next question, just type next. Of course, you guys know I'm solely depending on your response for me to proceed. I'm really and rightly available, depending on your response for me to proceed. That means if your response is not coming forth, it means you're literally saying I should wait. But I am suspecting that you're ready for me, so let's move to the next question. I am only suspecting that you're ready for me, so let's move to the next question. Is that true? If that is true, then please let's move to the next question. If that is true, let's move to the next question. And this question is saying that a rod, I'm no longer numbering the question. I don't know what question number is this. Class, what question number is this one I'm solving right now? A rod length 10 centimeter is heated through somebody say question 6. That means we're making good progress. Is heated through 100 degrees Celsius, and I think its final length is 10.26 centimeters. Now the big question is, what is the linear expansivity? What is the linear expansivity? If you're a smart person, you notice that I'm treating a lot of subtopic under heat energy, and I'm solving questions from each of these subtopic under heat energy. That is just to reveal to you that we are literally covering heat energy. So you should take this seriously. I am not just facing one direction. I'm just covering heat energy, so that if I'm entering electricity, the next time we do a lot of questions on electricity. If you're entering magnetism, we know we are entering magnetism. If we are entering waves, we know we are focusing on waves. If it is mechanism, we know we are on mechanism, dimension, all of that. Do you understand? Do you understand? The life is dropping. The life is dropping. This shows that you guys are not sharing the life. That means I will just solve. I think I just have 4 minutes or 6 minutes left. Let me just finish with this one, then I'll go rest. I think we've done a lot, because I'm not seeing the support coming from you guys. Okay, let's solve this real quick. So since you're asked to find the linear expansivity, what is this linear expansivity? I really do not want to do some definition. I just want to go straight to solve. Is the increase in length per unit length per degree rise in temperature. It's quite very simple. So linear expansivity, I can use this alpha to represent the linear expansivity. It's always talking about the increase in length per unit length per degree rise in temperature. Theta 2 minus theta 1. So that's the formula for this linear expansivity. So be that as it may, what are the values given to us? Let's work on those ones. But do you notice something? Do you notice that these things are given in centimeters? Please make sure to convert them from centimeters to meters. Please do make sure to convert these things from centimeters to meters. So that means we will have our L1. Our L1 is given, the first length you're having there is 10 centimeter. So if you're converting these 10 centimeters to meters, are you dividing by 100 or you're dividing by 1000? Guys, talk to me. Are you dividing this 10 by 100 or 1000 when you're converting from centimeters to meters? Somebody is saying divided by 1000. It can never be 1000. You're only going to be dividing it by 100. That will not be in meters. So therefore our L1 is going to be, is it 0.1? 0.1 meters. I've converted it from centimeters to meter. Is it 0.1? Please, it's not dividing by 1000. It's going to divide by 100. Please learn that one so you don't make mistakes next time. Learn that one so you don't make mistakes next time. So what about L2? L2 is this particular length given to us also, which is the final length. L2 is given as 10.26 centimeters. Let's convert that to meters. That means we have 10.26 divided by 100. Please guys, divide this and tell me the answer. 10.26 divided by 100. What's the value? Is that supposed to be 0.1026 meters? Confirm if that's correct. Awesome. Awesome. So the thetas are the value of the temperature. Of course, as you can see, you only just have just one temperature given, which is this particular 100 degrees Celsius. So you don't need to expand it like this. You could just leave it as only theta or change in theta. But because we just have only 100 degree, we just have only one value. We're not going to be having this 2 1. Like, I mean, for us to get this, remember the official formula is increase in length per unit length L1 per unit change in temperature. This thing is what I expanded because delta means change in length, L2 minus L1. This delta means change. This means change. So since we don't have what to change for the temperature, we just keep it as only theta. So if you plug everything into the formula, we have L2, which is this value, 0.1026 minus L1, which is 0.1, divided by L1, which is 0.1, multiplied by the theta, which is this theta. What's the value? 100. We just have 100. So when you subtract this, what do you have, guys? When you subtract 0.1 from 0.1026, what do you have? Or can somebody do all the computation and tell me the final answer if you cannot be able to give me the answers individually? Or somebody says 0.0026. 0.0026. Is that what you say? What is 0.1 times 100? What is 0.1 times 100? What is 0.1 times 100? Guys, 0.1 times 100 is what? 10. Okay, divide this value by 10. What do you have? Divide the value by 10. What do you have? 0.0026 divided by 10. What do you have as the final answer? Somebody says 0. Is that 40? 0.00026. So the unit for this guy, if you like, you can keep the answer in standard form. If you move the decimal point 1, 2, 3, 4 times, so you can have it as 2.6 times 10 to the power of minus 4. You can leave it like this, you can leave it like this in standard form. But remember, the unit is per degree. I think per degree, right? Per degree Celsius. All right, that's all from me today. To you, I hope you enjoyed today's class. Next time, if I say I'm coming to live stream, whether on YouTube or on TikTok, what I expect you guys to do is to share that particular information everywhere. Because when I'm mentioning that, I also mention the name of my page and where I'm going for the live, and also the time. You make everything easier for them by you sharing the post I made on the information on the live, and also share the link so that people can go subscribe and wait. If it is TikTok, same thing. But some of you will see the information and relax. You're just going to wait for when I come live. You could just come and enjoy alone. That's not cool. You know, you guys are family. You are my family. You are my family. It's only you guys that I have. So you need to support me as well. Always sharing my life and all of those things. But I love you guys regardless. I love you guys regardless. Thank you so much for enjoying my lesson today. I'm going to post this video on my page so that you guys will have time and also watch it next time. Until next time, I'll also update you the next class. Take care. Love you guys. Bye bye.